Alright, so I'm going to just show you how to run SomaticSeq on precisionFDA. It looks a bit complicated. So this is the SomaticSeq app on precisionFDA. It is essentially just SomaticSeq parallel. So you can only run it after you have already run some of those individual somatic mutation callers, such as Mutec, in the locator, varscan, somatic sniper, and for more details, you should just go to the GitHub repo to see the documentation and explanations. So this is just to show you how to run it. Your run app. I'm not exactly sure what's the best instance to run here, but hide disk 36 runs successfully, so I'm just gonna go with that. So if you're just running consensus mode, if you don't have any truth file to run training, I would pick false. And since there is no training or classifier, the algorithm doesn't matter. Here you can either choose XGBoost or Ada. XGBoost is in Python. Ada was originally implemented in R. So, all those files are required. FastA, here's just an example of getting the right FAST8 file. That's the human genome reference. You need to select the .fai file as well, and also the dict file, which is required for sorting. dbSNP, those are optional. You can see that there's single and pair mode. Single means you only have one band file. Pair means you have tumor and normal paired band files. In this case, I'm just going to skip dbSNP, truth file. We don't have anything to train here, so skip those. Output that will be actually made into like a .rar file. Let's just say SomaticSeq test 2021 12 14. Classifier, those are actually trained classifier if you have those. I'm going to skip them for the time being. You can try those things later. Inclusion bed file, to make things a bit faster, I'm going to take this exome bed file. It is recommended that even you are running whole genome sequencing, you should have a bed file with the major contigs, because otherwise some of the callers is going to spend a lot of time trying to make some other mutation calls in those decoy contigs, and those are just going to be a waste of time. Exclusion bed file, those are the regions that you don't want to run. I'm going to skip those for now. Pass threshold, those are only useful in classification mode. So when XGBoost or AdaBoost gives a score, this is the threshold above which a pass will be labeled 0.1. So if it's greater than 0.1 or less than 0.5, it's going to be labeled a low quality, and less than that will be labeled a reject. We're just testing for consensus here, so these things actually don't matter. Those are minimum mapping quality for which the reads will be used. Base quality, so we can skip these things for this test. So minimum pass calls for variant caller, so same thing. So it's a consensus call. So if a variant call has been made by like one caller, it will be included in the evaluation. But sometimes, I will give this number like a 0.5 if a call is low quality. So you can just leave it as default. That's the C for XGBoost, treat depth, number of iterations. Since we're not doing training or classification, we can just leave them since they're not going to be used. Tumor normal means paired. So for paired, you're going to need a tumor band file. It will be this one. And normal band file. See, in pair mode, you need the normal band file. Normal band file. Now, precisionFDA it's not going to automatically include some of those like index files, so you have to explicitly point to them here as well as here. Make sure that's the .bai index file, so tumor normal. Mutex version 1, so we have used Mutex 2, so that's output from Mutex 2 that we have previously run somewhere else. We can include that. We can also include Vardict. This is an example where I run Mutex, Vardict, and Stroka. See, so some of those are only for single mode. So for instance, Low Freak actually has a paired mode and a single mode, but in the single mode, the indel and SMVs are together, so there's just one Low Freak VCF if you're in single mode. And if you're running pair mode in Low Freak, you actually have SMV and indel separate. So if you have run Low Freak and you want to incorporate this result based on whether it's a single or paired mode, you should be careful not to use the wrong one. All those things are kind of optional. Let's include Stroka, right? So for pair mode, there is a SMV and indel files. They're separate for Stroka. SMV and indel. So those are the input files. Then you can just click Run App. It is going to run. Now, I know it should run successfully because I've done it before. So a successful run would be something like that, and you can see the results. So the result for a successful run would be something like that, and you can download it. Let's just try to download the results from precisionFDA download. All right, download into temp folder. All right, so that's the file we downloaded. That's the result. I have alias for tar. You go into it, then those are the consensus result for SomaticSeq. Right, so let's look at the VCF file. This is a call that's labeled pass based on consensus. Two tools have called it. MDK stands for Mutex, Vardict, and Stroka. So Vardict and Stroka has called this variant call, but not Mutex 2, and so that's why number of 2 is 2, and it's labeled 0, 1, 1. This call, whereas all the callers have called it. So that's how you run SomaticSeq on precisionFDA.